So let's consider the example we used to solve the shooting method. Remember, our fixed cost is 189 and then our inventory waiting cost is 10. From what we get, our optimum headway should be given by square root 2CF CI divided by CI and the demand rate. So let's see, our demand rate is given by 100 for 0 to 1, 80 from 1 to 2, 50 from 2 to 3. So our optimum headway should be okay. So we can get the value 0.6 around here, 0.68, maybe a little bit higher, 0.89, 869, a little bit higher. So we can have this step function. Okay, now let's convert this optimum headway function into the solution. Remember, we need to draw the 45-degree lines. So let's see, how did we do that? So first, we draw a 45-degree line. And then, fortunately, this is a constant function. So our first point, P1, should be exactly 0.615. But then our intersection should be this point. So this is our P1, which equals to 0.615. Okay? And then we need to draw the 45-degree line from T1. We just zoom in to find out how do we determine T2. We got T1, 0.615, and then this is 1. We jumped to 0.687. So if we draw the 45-degree line, it should be in the middle, such that the area below this line with our step function equals to the area above this line. So in this case, we can approximately calculate that. So that means this height, let's see, this is x. This height, let's see, this is y. We can have x times 0.615 should be equal to y times 0.687. And then x plus y should be 0.687 minus 0.615. So after we solve this, then let's solve it. The first one tells us, the first equation tells us y equals to 0.895x. And then after we plug into the second line, it can tell us, okay, so this tells us this height should be 0.615 plus 0.038 to 0.653. So our T2 will be, which is 0.615 plus 0.653. Now let's draw another 45-degree line. So in this case, we have the intersection at 0.687. So that tells us our T3 equals to 1.955, which is 1.268 plus 0.687. And then the final shipment, if you draw another 45-degree line, so we'll get some value here around 2.7, which is pretty close to Tmax. So we can stop here because definitely there will be some error when we do approximation. So in this way, we can get our optimum solution where the shipment time should be 0, 0.615, 1.268, and 1.955.